This experiment is on electromagnetic induction. The very basic experiment that Faraday had done for finding out this phenomena. A coil and a magnet. Whenever you move a magnet towards a coil or away from the coil, there is a current in the coil. That is known as electromagnetic induction and induced current. That motion is necessary. If you just keep the magnet near the coil, nothing will happen. But if you move the magnet or you move the coil, then there will be a current, there will be an induction, and the current will flow. So here is the coil. You can see this is about 1000 turns of a wire wrapped on this particular reel, and then after those 1000 turns, more than 1000 in fact, there are two ends, and those two ends of the coil I have connected to this plastic wire. At the end of the wire I have put two LEDs, two special LEDs. One is green, one is red. They are connected in a special fashion. I'll tell about that later. Now what I will do, I will bring a magnet towards this coil. You can see there is a hole at the center. I'll push the magnet inside that hole, or I'll take the magnet out of that hole. So when I do this, there will be a current through this lead wire. It will reach these LEDs, and then the LEDs will glow. So if the LEDs glow, you know that current is induced. Okay, so now I am doing it. Where is the magnet? See, I am taking the magnet in and out, in and out. The LEDs are glowing. If we are not able to see it now, don't worry, I'll come to you and show it in close up. Yes, this time green is lighting, this time red is lighting. So when I am taking it in, green is lighting. When I am taking it out, then red is lighting. Now see, green, red. I am taking the magnet in and then out. When I am taking it in, the green is lighting. When I am taking it out, red is lighting. Only one of them at a time, but alternately green and red. You can now see these LEDs lighting. No battery connected, no source of current I am providing from anywhere else. It's only the movement of magnet which is doing this magic. See, this is how I am doing. I am taking the magnet inside this coil and I am taking it out, and that is creating this electromagnetic induction. Why I have put two LEDs? You know, LEDs are light emitting diodes. A diode allows current only in one direction. There is a positive end of the diode, there is a negative end of the diode. I have joined positive end of one diode to negative end of the other diode, green and red, and the negative end of the first diode to the positive end of the second diode. So when I take the magnet towards the coil or away, current tries to go from one direction to one end to the other end. The LED which has positive end in that starting direction will glow, the other will not glow. When I am taking the magnet away, the current tries to go in opposite direction, then the other LED will glow. So that is why I have put these two in this particular fashion. So when I am taking it, when I take it in, the current tries to go in one direction, and therefore only one LED will glow, because it is diode. The other LED, for that it is a reverse current, will not flow. When I take it out, then for the other diode it is the right favorable path. Current tries to go from the opposite direction so that other LED glows. So that is how. But the main important point is, whenever there is a motion, relative motion between the magnet and the coil. I am taking the magnet in or out, then an induced EMF is produced in the coil. Normally battery is used to pass current, but here by the motion between coil and magnet we can produce electromagnetic induction, EMF and current in the coil. So that is Faraday's law, Faraday's induction.